Let's try a second example, bit different. Alright, x squared minus 8x plus 13. Follow exactly the same process. The first thing to do is to look at the coefficient in front of the x term. And we find that a half of minus 8 is minus 4. And then we want to square that. So minus 4 squared will be 16. So we have x squared minus 8x plus 16. So that plus 16 has now changed the expression, and that means we need to subtract 16. Now the expression is all back to normal, and we have the plus 13 that was originally in the expression. Because we added this 16 to the expression, we'll end up having this part of the expression is a perfect square. In fact, I know that that will be, when I factorize it, a perfect square of x minus 4 all squared. I know that. That's the whole purpose of perfect squares and why they're so important throughout all of mathematics. And this final bit here, the bit that is the minus 16 plus 13, that gives us an answer of minus 3. It's just a coincidence that we've ended up with a minus 3 again. Okay, and we're going to reinterpret that minus 3 so that we'll have an expression of x minus 4 all squared minus the square root of 3 all squared. And now we've got a difference of two squares. And what we're going to do is factorize that, put that into brackets. We'll have x minus 4 at the front of the first set of brackets and x minus 4 in the front of the second set of brackets. We'll have a plus and we'll have a minus, and there'll be a root 3 there and a root 3 there. And finally, if I remove those brackets that are around the x minus 4, we'll have x minus 4 plus root 3 times x minus 4 minus root 3. And that can't be factorized any further. Alright, let's do a third example. We're just following exactly the same process. X squared minus 4x minus 3. We look at that coefficient in front of the x term. It's a minus 4. If I find half of minus 4, that will be minus 2. And if I square minus 2, that will give me plus 4. So on the next line, I'm going to have x squared minus 4x plus 4 minus 3. And that means that this part of the expression will be a perfect square. And I can factorize that to be x minus 2 all squared. And the last part of the expression here, minus 4 minus 3, that gives me minus 7. Now I think of the minus 7 as a square root of 7 squared. So we'll have, in the next line, x minus 2 squared minus square root of 7 squared. That's a difference of two squares. And when I factorize that as a difference of two squares, I'll have two sets of brackets. And there'll be x minus 2 in the first set of brackets at the front of the first set, and x minus 2 at the front of the second set. We have a plus sign and a minus sign. And the last thing that goes in both sets of brackets is the square root of 7. Let's try another one that's maybe a little more difficult even than these ones. Right, so here's a non-monic quadratic trinomial. This process of completing the square only works if we have a monic quadratic trinomial. It will only work when the term in front of the x squared is a 1. If I look carefully at all three terms here, I have a 3, a 24, and a 6. There's a common factor of 3 that will go into all of those. So what I'll do is, to start with, I'm going to take out the common factor. And in fact, with any kind of arithmetic or algebra where you're doing manipulation and factorization, the first thing you should always do is to take out the common factor. So the common factor here is 3. And what we'll be left with inside the brackets is an x squared minus 8x plus 2. And now we can complete the square for everything that's inside the brackets. Put the 3 out here, I have x squared minus 8x minus 4 squared will give me plus 16. So I put in the plus 16, but I have to remove that so that the expression has exactly the same value. That's the whole purpose of adding the plus 16 and minus the 16. So the expression has the same value as it was originally. And now I know that this part that's in the blue brackets will be a perfect square. So I write that as 3 outside of, the perfect square for this is x minus 4 all squared. And then when I look at this part at the end, minus 16 plus 2, that's going to give me minus 14. So we have minus 14 there. And we do the usual process of thinking of this minus 14 as going to be the square root of 14 all squared. So we'll have 3 outside of x minus 4 all squared minus square root of 14 all squared. And now this part here is a difference of 2 squares, and it will factorize, if you haven't picked up on this already, to give me a beautiful 2 sets of brackets. And in fact we're going to have x minus 4 plus root 14 and x minus 4 minus root 14. Now it's time for you to practice.